Hi guys, today in this video we are going to see about an SR flip-flop working in an Verilog HDL programming language using the Quartus 2. So let's see into it. So for doing this program we have to import the module and the file name what we have like SR/FF, and inside the bracket we have to insert the inputs and outputs which are required for the program, like SR, clock and reset are the inputs and Q and Q bar are the outputs. So after doing that, we are going to initialize again that these are the inputs and these are the outputs. Like input S R clock and reset, and the outputs as Q and Q bar. So after that, we are getting into the function, getting into the program. Like for synchronous reset, we are using this function like. Always at positive edge of clock we are going to begin it. So inside that we are going to use an if else statement. So if the reset is not a null, then we are going to give it as q is less than or equal to 0, and else we are going to begin a case where s comma r are the inputs. So if 0 and 0 is the input, then the q is less than or equal to q, which is there is no change. And then if s and r are 0 and 1, then the q is less than or equal to 0. And then if the s and r are 1 and 0, then the output is q is less than or is equal to 1. And finally if s and r are 1 and 1, then it's an invalid state of output. So after doing these cases, we are going to end the case, and then again we are going to end it because we have begun here. And finally again once more we are going to end it as we are behind for this function. So after that we are assigning as q bar is equal to an complement of q, which is nothing but the output what we get for the q, which, and then the complement of that queue is what the queue bar. So we are assigning it at the last, and then we are ending the module. So now let's check how the RTL viewer looks, which is a real-time logic diagram. So for looking into that, we are going to tools, netlist viewers, and then RTL viewer. So this is how the RTL viewer looks. So here there are four inputs like yes or clock and reset, and then two outputs Q and Q bar. So this is how an SR flip flop works. So now let's see the waveform editor. So here it is. So here also we have four inputs: the clock, reset, S and R, and then finally two outputs Q and Q bar. These outputs are slashed as we didn't run this. So now let's see the clock. We have given like 20 nanoseconds for all, and then for reset we are given 0 for one state, and then 1 for all the states. And for S and R we are giving it like 0 0 0 1 1 0 and 1 1. So now let us run this and check. We're going to simulation and run functional simulation. It's running. So this is our output. So we could see that the Q and Q bar are not slashed. So we have got some output like zeros and ones and zeros and ones. So whatever we got for the Q, that complement is what we have got in Q bar. Like how we saw in our program, we have assigned like Q bar is equal to a complement of Q. So this is how an waveform editor for this SR flip flop. So thank you for watching this video.